Okay, let's take a look. All right, so what are we going to do here? Somebody help me out. If I want to rewrite this formula, I want to solve it for M1, what are we going to do?
Did you divide M2 by R2 first?
Okay. Say that again.
Divide M2 by R2 first?
Okay, but now let me rephrase this. Let me make this a little clearer. I don't know. I'm not pretending I know the values of those right now. I'm trying to come up with a different formula. What I want to end up with is that M1 by itself. I want M1 equals a bunch of other stuff on the other side. So just like we did the other day, if I want to get the M1 by itself, I got to push all that other stuff to the left, right? And what are the steps I go through to isolate something like M1? Well, there's my order of operations tree that tells me. First, I'm going to add or subtract stuff, but do I need to? No. What do I need to do?
Divide M1 out.
Okay, now, that's something that's a common thing that comes up. A lot of people want to move that M1. I can leave it there. The M1 is the one thing that we're maybe not going to, that we're going to leave it alone. That's the one thing that stays. Everything else on the right side we got to get rid of because our goal is to isolate the M1. So what are the algebra steps I would go through to isolate M1?
Divide by G.
Okay, for one thing, I'm going to want to divide by G, aren't I? Right, because I want to get the G off the right side, and right now G is being multiplied by M1. So if I divide both sides by G, it's going to cancel from the right side. That's good. Okay, what else?
Times both sides by R2.
Okay, by R, how do I say that?
R squared.
R squared. Good, I'm going to multiply both sides by R squared. And that's going to cancel the R squareds. What's the last thing I've got to do? Okay, if I divide both sides by M2, I got it. How about that? Right? I got the M1 by itself. It is equal to, and it doesn't really matter the order. Now, there's a couple things that do matter and some things that don't matter. It doesn't matter the order in which I'm multiplying two things together. I'll just pick the most convenient order. I'm just going to put the F first, but it doesn't really matter. So I've got FR squared, and on the bottom I've got G M2. Okay. That's my formula. Now, ideally, I probably want to also do one other thing. I don't really want to have, I'd rather have the thing that's by itself be on the left. Of course, I can flip that equation around, right? That's okay to do. So I might do this instead. Let's go ahead and get rid of that M1 from there. And write it right there. Okay. Make sense? Okay, and what about the other issues here I had to look at? What about evaluating these things? What is, we'll start easy here. What is -2 squared? 4. And what I really mean to say there is the quantity -2 squared. What does that mean when I square a number? Multiply by itself. So this is really just equal to -2 times -2, which is +4, right? Okay. Now what about,
Good luck.
what about the quantity -2 cubed? -8, good, because if I multiply -2 times -2 times -2, I'm going to get a negative answer, aren't I? In fact, let's generalize this. I'm sure you know this answer, but let's just say it so we can clarify it for ourselves and others here. If I take a negative base to an even power, what can you tell me about the product always? It's going to be positive. Good. A negative number to an even power means that I'm going to multiply a negative number an even number of times, and so I get a positive result. What if I take a negative base to an odd power? It's always going to be negative, isn't it? Because that's the same thing as multiplying a negative number times itself an odd number of times, right? So I always get a negative result. Okay, now here's the part, and we can, by the way, we can we can demonstrate this stuff on a calculator too. If I pull up, oh, and I got to say something about calculators. If I pull up a nice TI-84 Plus Silver Edition, which I got to tell you about, I think I've forgotten to until now. We're going to do an order at the school like we did last year. I don't know if you knew about this, but you have an opportunity to get a TI-84 Plus Silver Edition, which is normally, I think somebody told me last period it's $117 or something like that, for $78. You can get it $78 through the school. Great deal. So here's how you do this. The order goes out on October 3rd, so I gotta have your money before October 3rd. You can bring cash, but a check is probably better. Just make the check out to PHS. Okay, but this is a great opportunity. We're going to do, graphing calculators are going to be an absolutely essential part of the class. Every test we take, there will be two parts to it. There's going to be a non-graphing calculator part of the test, where you can't use a graphing calculator, which is sort of more algebraic and things like that. But then there's always going to be a graphing calculator part also, where you will have to use a graphing calculator, because it's an important tool in math, and if you don't know how to use it going to college, you're going to be stumped. And there are things that you just have to know how to do, like regressional analysis and statistical stuff, and using graphs to evaluate. And there's all kinds of really important things for you to be able to do. It's going to make your life much easier, but you're going to have one. In college, it's absolutely essential. They will, in fact, it'll be 9 times out of 10 when you go to college, it's going to be required. They're going to give you a textbook list of things you have to buy and a calculator that you have to have. And it's usually this one. I mean, this will work in all cases, I'm sure. So take advantage of that. It's a great deal. Questions about that? $78, October 3rd. Checks payable to PHS. Yes, sir. You can pay cash. That's fine. You can. It works. Cash is fine. Yep. Oh, so you've already got one. Okay. Yeah. You got the Inspire. Yeah. That'll work great. Yeah, and I think, doesn't that work just like an 84 also? If you put it in a mode where it works just like an 84?
It has like different places you have to go.
Yeah, okay, is there a faceplate you can put on it that makes it look like an 84 though? There used to be, maybe there's not anymore. May not be. Well, we'll take a look at it. I've never really used those, so I'm a little unfamiliar, but I know they're very good calculators. Okay, any other questions? Calculator questions? Okay, back to business here. Now watch this. Oh, non-silver's fine. Yeah, that's fine. Okay, see what the calculator tells us. Good, it tells us, just like we'd expect, that the quantity -2 squared is 4. Okay? But what about this guy? Watch what happens. And the calculator is smart. It knows what it's doing. If I put in -2 squared, am I going to get 4? No. I get -4. And that's correct. That's correct. Because what I actually asked the calculator there was maybe not what I intended. Maybe it was, maybe it wasn't. But if I want to know what the number -2 squared is, that corresponds to this. Okay? How come this gave me a different answer? Because it's not -2 squared. What that really says is negative the quantity 2 squared. If I follow order of operations, watch what happens. Okay, we know that exponentiation, if we're taking exponents, comes before multiplication, right? And so when I see an issue like this guy up here, if I follow order of operations strictly, I have to square the 2 before I multiply by the -1. Because something I want you to always remember, the easy way to think about this, if I have a negative sign in front of something, anything, always what that means is -1 times that thing. So if the number -2 is literally -1 times 2, right? And so I don't get to apply that negative sign or multiply that negative sign into this until I've already squared the 2. And so my answer is -4. See how that works? So what's the moral of the story here then? If you want to square a negative number on your calculator, what must you do? Put it in parentheses, yeah. Okay.